Hi students, in this video we're going to look at the unit circle and how we use it to calculate trigonometric ratios, so sine, cos and tan, of angles that are bigger than 90 degrees. Now after watching this video you should be able to understand what the unit circle represents. You should be able to understand how the coordinates of a point on the circle relate to the sine and cosine of an angle between the radius and the x-axis. Identify the quadrant in which an angle lies and whether sine, cos and tan of that angle is positive or negative. Then also we want to express tan in terms of sine and cosine. There's a lot there and a lot to cover, so not many worked examples in this video, just a few explanations going over this very important idea of the unit circle. Big thing we have to recall are our trigonometric ratios sine, cos and tan, and how we calculate those and the formulas we use to calculate them. Alright, so when you were first introduced to trigonometry earlier years of maths, it was done in the context of right angle triangles. So sine was opposite over hypotenuse, cos was adjacent over hypotenuse. All of the triangles we used had to deal with 90-degree angles and right angle triangles, and that was the basis of our trigonometry. So that means for our right angle triangle we could only really find sine, cos and tan of angles that were smaller than 90 degrees, right? The angles of our triangle added up to 180. All of our triangles had that right angle, so all of the other angles in our triangle had to be less than the remaining 90 degrees left over. So finding sine of 60 and sine of 25, cos of 31.82 degrees, that we can always do because we could make a right angle triangle with those angles in it. Now, when we started using the sine and cosine rules, we started having to find sine and cosine of larger angles like 130 degrees. And that makes sense because if trigonometry is about triangles, there are some triangles that have obtuse angles bigger than 90 degrees. And so finding sine and cosine of those angles, we had to do as well. Now, conceptually, how do we do that? How do we make sense of finding sine of 135 degrees or tan of 172 degrees? How can we actually do that? How does it actually make sense? Now, this comes down to the unit circle, and not only will it help us find angles, sine, cos and tan of angles larger than 90 degrees in our triangles, it can even help us find sine, cos and tan of angles larger than 180 degrees. So finding tan of 200 degrees or cosine of 718 degrees. We can do those things once we have a firm understanding of this guy here known as the unit circle. Alright, so a few things to consider about the unit circle. So it's got a center at 0, 0, which is here on our picture. And it's got a radius of 1. That's why it's called the unit circle. It's got a radius of 1 unit. Now, the angle here, we've got theta, is this angle here. So we measure it from the x-axis and we measure it clockwise towards the y-axis. So that angle is theta. Now we've also got our quadrants listed. So these are just the quadrants of our Cartesian plane. So our first quadrant is in the top right, second quadrant is top left, and then working our way anti-clockwise, third quadrant is bottom left, fourth quadrant is bottom right. Now, looking at the triangle we've drawn here, so with theta and our radius of 1, we've got a right angle in here, and we can use our values here to help work out trig ratios in terms of x and y. So looking at our point at the very top here, it's got an x value, let's call it x, and a y value of y. Now, in terms of our Cartesian plane, that means this distance along the bottom here must be x. And this, because our x coordinate is just x. Our y coordinate here is y, and that's how high we've gone. So that there is our y coordinate. Now looking in terms of trigonometry, we can label our sides. 1 is our hypotenuse, y is our opposite, x is our adjacent, and we can get sine, cos and tan for that angle theta just by looking at the x and y coordinates of this point on the very edge of our circle. So the sine of our angle theta is going to be opposite over hypotenuse, so y over 1, which is just y. So with our unit circle, the sine of this angle theta is equal to whatever the y coordinate is on this circle. In the same for x, right? X is our adjacent side, so cos of our angle will be x over 1, adjacent over 1, which is just x. So the cos value of this angle is just the x coordinate of this point on the circle, where we've got our radius of 1 and our angle to the x-axis. Tan is our opposite over adjacent, that'll be y over x, which we can also rewrite as, given the information we got at the start here, y is sine x, sine theta, x is cos theta, so we can express tan as sine divided by cos. A bit to take in, but the key idea is any point on this circle, if we find the angle it makes with the center, the x and y values of that point on the circle give us the sine and cosine of the angle it makes at that center point, theta. All right, now a few things to note about the unit circle. As we've discussed, the coordinates of that point on the circle are cos theta and sine theta. So we just saw the x value is equal to our cos of our angle, and the y value is equal to the sine of our angle. We just worked that out. Now what that means is, depending on the quadrant in which we find our angle theta, we can say that the sine, cosine, or tangent ratios are positive, negative, 0 in some cases, or even undefined. So for example, in this situation, we've got our theta angle equaling 120, 5 even. Now over here, we can see our x value is going to be negative something. We don't know what it is, right? But we can say, because our x value is negative, our cos value of 125, because cos is equal to the x value, that value is negative. Looking at our sine value, well, our sine up here, that's a positive y value. So sine 125 is going to be positive. And because we can see it's got a positive value when we read it off our graph, because our y value is the same as our sine value for 125. Now for tan 125, well, we just saw in our formula that was sine divided by cos. So if sine is a positive number, as we've just stated, and cos is a negative number, as we've just stated, a positive divided by a negative number will be negative 2. So looking at our unit circle, we can see that cos of 125, it's going to be negative, sine of 125 will be positive, and tan, sine divided by cos, will be negative as well. Now looking at our diagram here, we'll work our way around first, second, and third quadrant and work out whether the signs are positive and negative. Right, in our first quadrant, our x value, our y value is positive. So our sine value for any angle in that first quadrant between 0 degrees and 90 degrees, that's going to be positive. Our x value is also positive. And then for tan is going to be a positive number divided by a positive number. So tan, for anything in that first quadrant between 0 and 90, will be positive. Working our way around from 90 to 180. So that's in our second quadrant now. This time, the y value, well, it's still positive, right? So our y value up here is still positive, but our x value is now negative down over here. So looking at that, our tan value will be a positive number divided by a negative number. So our tan value will be negative. Now continuing on to the third quadrant between 180 degrees and 270 degrees. Right, our y value is now negative. So sine of any angle between 180 and 270 will be a negative number. Our x value is still negative in that quadrant, right? So cos of any angle between 180 and 270 will be negative. And then for tan, a negative number divided by a negative number makes tan positive. Finally, in the fourth quadrant between 270 and 360 degrees, our sine value is still negative. Our cos value has become positive at the very top here. And then for tan, a negative sine value divided by a positive cos value gives us a negative tan value. So using that table and using the idea of those coordinates giving us cos and sine, and dividing them giving us tan, we can work out in each quadrant whether sine is positive, negative, in each of those quadrants. So to help us remember which ratios are positive in each quadrant, we use a mnemonic. We might use the mnemonic all stations to central. So what that means is in the first quadrant, all of our trig ratios are positive. Looking in the second quadrant, only sine is positive. So all stations. In the third quadrant, only tan is positive. So the others are negative. So all stations 2. And in the fourth quadrant, only cos is positive. And so it's all positive in the first, only sine in the second, tan in the third, cos in the fourth. All stations 2 central is the mnemonic that's used to help us remember which ratios are positive where. All right, so looking at this here, we can do a couple of quick examples, determining the quadrant that it lies in and working out if those signs are positive or negative. So 330. So we've got our angles here. There's 0, 90 at the top here, 180 over here, 270 at the bottom. So 300 will be down here somewhere, all the way around, giving us 300. So for 330 degrees, that's in the fourth quadrant. So we've got all stations to central. So in this quadrant, only cos 330 degrees is positive, and all the other values, sine 330 and tan 330, are negative. For our second one, 195, so 180 is over here, so 195 might be around here. So looking at that one, that's in the tan quadrant, so only tan 195 is positive. So sine 195 and cos 195 are negative. And that's how we can locate angles and work out whether they are the trig ratios for them are positive or negative. All right, finally, we are going to look at our special angles. So we've got 0, 90, 0 degrees on our x-axis, 90 degrees on our y-axis, 180 on our negative x-axis, 270 at the bottom, and then back to 360 at the end there. Now remember, we can also calculate our sine and cos values by knowing the x and y coordinates. So looking here at 0 degrees, our x value is 1 and our y value is 0. So looking at our table, for 0, our sine value, our y coordinate is 0, our x coordinate is 1. Then to find tan, tan will be 0, our sine value over 1, which will be 0. Working our way around, 90 degrees, that's 0, 1. So our y value, the sine of 90 degrees is 1, the cos, the x value of at 90 degrees, is 0. Now, what happens here is quite interesting. Tan will be our sine value 1 divided by our cos value 0, which is undefined. So tan of 90 degrees does not exist. Continuing to work our way around, x value is -1 and 0. So our sine value is 0. Our x value is -1. So cos of 180 is -1. Tan 0 over -1 is just 0. 270, that's 0, -1. So our sine value of 270 is -1, all the way at the bottom there, because that's our y value. Our x value is 0. So cos of 270 is 0. Tan will be -1 over 0. Once again, undefined. 360, we get all the way back around to where we started at 0. So that'll be the same as 0 degrees, 0, 1, and 0. And that's how we can use our unit circle again to help us work out the trig values of our multiples of 90 degrees, 0, 90, 180, 270, 360, and so on. Alright, so students, a long video there explaining the unit circle, but after watching this video you should be able to understand what the unit circle represents, understand how the coordinates of a point give us the sine and cosine of the angle that it makes with the x-axis. So the sine was our y value of our point on the circle, the cosine was our x value on our point of the circle. Identify the quadrant in which an angle lies and whether sine, cosine, and tangent of the angle are positive or negative. And for that, we used all stations to central for our first, second, third, and fourth quadrant, depending on where our angle lied, to work out which ratios were positive and negative. And then express tan in terms of sine and cosine. We said tan is sine divided by cos.